right, now some of these mistakes are going to be, things that a lot of people are familiar with, but I just had to make sure I covered it before, just in case you all made the mistakes. So let's go ahead with the first one here. The first one is, I notice a lot of people divide wrong, right? And I'm going to do two versions of this. When we're dividing this on our calculator, quick question, who gets divided by the 5? In the first question, is it a 4x or is it the 7? And I just want to point out, these mistakes are made usually because of pressure, because you're rushing, not because you didn't know. No. It's because you're just under pressure and you make mistakes. Right. So a lot of people are still making the mistake. Now, not everyone, but a lot of people are telling me it's the 4. And some people are telling me it's the -7. But some people are telling me it's both. And the answer is both. You notice you have one big divide sign here. So that means the 4x and the -7, both of them at the same point in time, get divided by the 5. So the real way of writing this is this. You divide the 4x by 5 and the 7 by 5. Of course, we could divide each one separately and put it in decimal form, or we could leave it in fractions. But if you decided to put it in decimals, you will get what? 0.8x minus 7 divided by 5 is 1.4. And then you can obviously simplify these two. 0.8 minus 1.4 is minus 0.6x. Everyone agrees with that? Guys, I'm trying to trick you here, and some people figured out the trick. No, guys, I'm purposely making an error here. Why did I do this last part? Is it possible to minus 0.8x and minus 1.4 without an x? The answer is no. All right. This answer cannot be simplified. Well, once you reach this point, this is the final answer. And I know most of you all knew that. It's just that you're probably tired because you had a whole day, right? Or I said it in a trusting voice. All right. Please don't make any of those mistakes in the exam. Another way, right? People make this same mistake with the dividing is when you have to transpose. And I'm seeing this a lot, even in the AdMaths class. So you want to solve for x in the second question. So we know what to do. We're going to throw across Mr. -4 to get what? +4. Fine. So 5x is equal to 22 plus 4. What mistake did I make? I purposely made another mistake here. Well, what's the mistake? Great, Ronis, you saw it. Right, remember this 5x had a minus. I never moved that minus. So I have to put it back. You see when a minus sign comes first in maths, you're not accustomed seeing that. So your brain is going to automatically forget it. But if there's a minus sign there and you didn't do nothing with it, you have to leave it, right? And now we can complete this question. Obviously, this one, now we could add the 22 and the 4, right? We could get 26, fine. There's no tricks there. And then the -5 is a multiply, throw it across, you get a divide. And what will we get here? 26 divided by 5 minus is -5.2, right? Just pointed out, and next I'm going to change this question slightly, just real slight, so you can see the comparison. If I had -4y, you notice for this 4, I put a y now. I want you all to try back this question with that simple change. And I want you to make back x the subject. Let's see if under pressure and after a whole day of doing work, if you're going to fall, if you are going to make a mistake. Let's see. So what we need to do now is throw across the -4y. So you throw across the -4y, you're going to get +4y. Now you cannot squish these two together because he has a y And the 22 has no letter, no y, so you have to leave it separate. So this is what you have so far. Minus 5x is equal to 22 plus 4y. The next thing now, you have to throw across this minus 5, which is a multiply. Now, you could put one big divide sign and put what? Minus 5. Remember, when you throw across a multiply, you get a divide, but the sign does not change. So it remains negative 5. So you can leave your answer like that. And nothing is wrong with leaving the answer like that. But if you want to separate it, remember, this means everyone on top at the same point in time, both of them get divided by minus 5. And if you decide to simplify it, you say 22 divided by minus 5. That's not 22 divided by minus 5 is minus 4.4. Positive 4 divided by minus 5 is negative 0.8y. And you cannot squish these two together because he has a y and he doesn't. All right, so the majority of people sent the correct answer. They either had this answer or they had this answer. And a few had this answer, right? Great. All right, so that's the first common mistakes, first set of common mistakes I noticed a lot of people were making. Let's move on to the next one quickly, right? This one here, and I'm going to spend too much time on this one, lucky for you all. Guys, when you're doing things like trigonometry, right? And you have angles, remember your calculator, right? Your calculator has, well, when you're measuring angles, it could be what? Degrees, it could be radians, and it can have something called gradient, right? Make sure for the CSEC exam, your calculator at the top here, make sure it's on degrees mode. Different calculators will have it different. Some calculators will have DEG, and some of them will just have the letter D. But please make sure you're seeing one of these on top. If you are seeing RAD, that is the wrong mode. If you're seeing GRAD, that's the wrong mode. Figure out, make sure for the exam, figure out how to change it to degrees, right? Not going to spend too much time on that one, okay? So let's move on to the next one. Great. Here's what I want you all to do. This is probably the most popular mistake made in matrices. I want everyone to quickly find the inverse of that matrix. I know I'm asking the question, what is the determinant? But first, take my advice. Find the inverse of this matrix, and then I will ask you, what is the determinant? I await your answer. To find the inverse, well, we normally say, hey, let's find the determinant first. So to find this thing called the determinant, where we multiply the leading diagonal first from the upper left to the lower right. So you say 2 multiplied by 5. As soon as you do that, you put a minus sign, and then you multiply the other diagonal, which is 6 multiplied by minus 3. 2 by 5 is 10. 6 by minus 3 is minus 18, and you have a minus sign waiting, so you get positive 18. So you get what? 28. Now, to find the inverse, we take the determinant and throw it underneath a 1. So we know that. Then we switch the leading diagonal. The other diagonal does not move. It just becomes the opposite. So it becomes minus 6 and positive 3. I mean, the signs become the opposite. So fine, we have the inverse. Now here's the thing. After you do that now, I ask people, what is the determinant? Choose the correct answer here. Is the determinant 28 or 1 over the 28, the item outside the inverse? 28 or the 1 over the 28, right? And the answer is 28, just boring old 28. You won't realize how many people on this chat said 1 over 28. And that has been an issue from since I teach in maths, how much ever years ago, all right? The 1 over 28 is part of the inverse, right? The 28 is the actual determinant. The rule is when you get the determinant, which is 28, in order to get the inverse, you have to throw it underneath the 1. All right, so let's keep that in mind because this is a 1-mark question, right? They could ask you to find the inverse and then ask you to do what? Pull out the determinant from it. It's the actual number, not the 1 over the number. All right, so let's move on to trick number 4, right? Right, so I want to stress on this one so you all come up with full marks in your exam. It's a good idea to always round off your answers to 2 decimal places. But rounding off your final answer to 2 decimal places in the exam does not mean you work with 2 decimal places. You should do your working to 3 decimal places, and at the end of the question, then round it off to 2 decimal places. So let's use an example here. Let's say we wanted to figure out, you have a ship over here and he's sailing towards an island, and we want to know how long it takes. Now there's this formula called distance is speed multiplied by time. I think we met this sometime this week. I think yesterday we met this formula in class. So if I want to figure out how long it would take, right? All I have to do is transpose to find t, right? Time is what? Distance over the speed. That's all we have to do. We have the speed of the boat is 8.5 kilometers per hour. But do we have the distance the boat is sailing? No. But couldn't you all use the cosine rule to figure out this distance? Remember yesterday we did this in class? We have 2 sides and the angle in between. Let me put in some letters for you here. P, Q, and R. Figure out the distance QR, and then we will have the distance, and we're going to divide it by what? The speed. All right? So we'll put in the common letters for you. Here's common P, here's common Q, and over here is common R. Solve for common P quickly for me. And remember, since we're working to 2 decimal places, I would advise, since we're doing our working, put everything to 3 decimal places, 1 more than what is required. All right, so let's substitute in some values, right? So I want to show you exactly how I would work this out in the exam. So this is the cosine rule when you're given 2 sides and the angle in between, and you want to find the one missing side. So we're going to put 22 squared plus q squared, which is 53 squared, minus 2 multiplied by 22 by 53 by cosine what? 123 degrees. So what I'm going to do, I'm going to work out this piece straight on my calculator. But when I work out this piece, when I'm writing down what I got, I'm going to go to 3 decimal places. So 22 squared plus 53 squared, 2 by 22 by 23 by cosine 123. I am getting this. You all can confirm this. 3844.174. You notice I went to 3 decimal places, even though it's 2 I'm working towards. But you see, I need to write this down for the examiner. And then on my next line, I will throw across the square to get what? A square root. I'm going to be square rooting this same exact thing on the calculator, right? Now, I know some people might not show this. They will just get the answer and square root it 1 time, right? So 3844.174, when I square root that, I am getting 62.001 Anybody else could confirm that? I just double checking it here. You see, I have to write down this to show the examiner I am about to square root something. And I'm double checking it here, right? I'm just making sure. I made a mistake, guys. When I worked this out, this was not the answer. It was 456.3.098 to what? To 3 decimal places. Right. Thanks for correcting me, guys. Thanks for correcting me. So what I'm going to do, I'm going to square root that now, 4563.098. And when I do that, I am going to get 6755. Now, if you look at it, I'll get a 1 here because I got a 0 and then a 7 after. So if I round it off to 3 decimal places properly. Now, the reason I did not round it off to 2 decimal places is because the question isn't finished as yet. The question is only finished when we take the distance, which is this, and divide it by the speed. Only then will the question be finished. So to calculate the time, the distance is 67.551 divided by the speed, which is 8.5. The examiner gave us that. When I divide this, 67.551 divided by 8.5, I will get 7.947 sorry, your answer will be in hours. Over here now, I mean, I could leave it to 3 decimal places, but only at this point, I would advise, since it's the end of the question, then round it off to 2 decimal places if you wish. But you see how I left it till the end of the question. Some people might have rounded off to 2 decimal places at this point, not realizing, wait, no, the question isn't finished yet. I did not answer the final question the examiner was asking me for. Do all of those things to keep the examiner happy. A happy examiner is a good examiner. All right, so everyone good with this one? All right, not examiner, corrector. I always call a corrector in the exam. Who knows? All right, so let's move on, all right? Right. How to divide, right? So I wanted to go through this one. And this is just an excuse to revise the hard cosine rule, but what I call the hard cosine rule. So you have x, y, and z. If we want to find this angle, anytime we have a triangle and we're given all 3 sides, we can use the version of, to find angle x, right? To find angle x, you all may have remembered this formula. Cos inverse, the big square brackets like this, and then, well, here's common x, here's common y, and here's common z. It will be z squared plus y squared minus x squared divided by what? 2 by z by y. Do you all think it's a good idea to type in this straight on the calculator? Or do you think we should take this in parts, right? And I've noticed lately, a lot of people are trying to type in the whole thing straight on the calculator. Well, I mean, it's okay to divide on a calculator without any explanation for simple situations. But when you have complex things like this, do yourself a favor, work out the top separately, write down the answer. Work out the underneath separately, write down the answer. Clear your calculator and then divide. And when you get it, cos inverse it. I want everyone to try this question for me and get the value of x. Pretend you only have 1 shot to get the correct answer, right? I'm just going to substitute in some of the values, right? So let me just substitute in the values here. Right, so it's z. So you have 82, 65, and 128. 82 and 65. So what I'm suggesting is that you work out the top separately, 82 squared plus 65 squared. And on top, I'm getting minus 54.35, and underneath, right, I am getting 2 by 82. Looking correct there? 10660. Right. So what we need to do is divide these two things. So let's divide the top by the underneath, and whatever we get, we could cost inverse it. So let's cost inverse. Let's divide. So 54. Anybody got 0.51? Looking correct? What simple mistake did I just make? What did we say in the slide before, right? Christian, you have it correct. Is the question finished? No, I should have gone to 3 decimal places. The question isn't finished. So I should have put 0.50. Well, sorry, this one, it don't make a difference. Sorry, because it's 0.5098. So never mind. Because if I go to 3 decimal places, I have to add 1 here. So this one here. All right. So in a case like this, it doesn't matter if I round off to 2 or 1 decimal places. I would still get 0.51. I don't have to put a 0, obviously. So that is my mistake. Not my mistake. I didn't predict that we would have gotten the same answer. But just in case, right, when you divide these two, the rules to get full marks in the exam is to still go to what? 3 decimal places. So let's cost inverse this now. Second function, cosine 0.510. And you all will have 59.336. But I'm allowed to go to 2 decimal places now because we've reached the end of the calculation. By the way, if you want to keep going to 3 decimal places, you can leave your final answer to 3 decimal places, huh? Right? But that's overkill, right? Work with 3 decimal places, and at the end of the question, go to 2. You're safe with that, believe me. All right, so let's move on. So the moral of this slide here, the moral behind this is when you have complex divisions to do it piece by piece. Do not type it in straight on your calculator. You will make mistakes. So let's move on to the next slide now. Right, so this one here is the Venn diagrams. Now the Venn diagrams are going to come in your multiple choice, right? I think they have removed the Venn diagrams from the structured paper, but we're still supposed to go through it. It's the use of the word only or alone. So let's say we have apples and berries. So a group of people like apples and berries. If I say 58 people like apples, where does that 58 go? Inside the circle or outside the circle? Well, if I just said 58 people like apples, the answer, well, the majority of the class got it wrong. The answer is outside. You see, when they make a statement like this, 58 people like apples, they mean everybody who likes apples, the entire circle, right? So that 58 represents the entire circle. So that means if over here is 10, I'm just saying if the middle is 10, how much is this portion here, the one with the dot? If the entire circle is 58 and they told you the middle section, the people who like apples and berries, if that is 10, how much is the dot? But then it will be 48, right? Because the whole thing is 58, you're minus 10 to get the balance. All right? Now, if I come and tell you 58 people like apples only, or I use the word alone. You can use any one of these words. Whenever they use the word alone, then it goes inside. But that 58 is only up to the boundaries. It doesn't represent the entire circle. So that means if I have here as 10, I'm just saying if the examiner came and told us, hey, in the middle there's 10, then the answer for the whole circle is 68, the 58 plus 10, but that 68 has to go on the outside now, right? So be real careful with that in the examiner, whether they use the word only or alone. Only or alone, the value goes inside the circle and it represents only up to the boundaries. It makes a world of a difference, right? All right, so be clear on that one, right, guys? That's number 6. Okay. This one here, the difference between f squared x and fx, the whole thing in brackets and then squared, right? I should have chosen an easier example for this one, so I'm going to change this question here, right? I shouldn't make it this complex for an explanation. Let's just call it this. Make it as simple as possible, right? Let's say the examiner gave us this equation. Fx is 5x minus 6. And they ask us to find, let's do the first one, f squared x. You notice where that squared is, right? It's hovering over the f. F squared x actually means f x, right? That means you are going to put, I have to give you a value. Sorry, I should give you a value, right? So if I ask you to find f squared, let's put 2 over here, right? That means f x, and we're pretending x is what? 2. That means we're going to put 2 into f, and whatever we get, we put it back into f, all right? You think you all could do that question for me? Because in functions, when they give you a value, we just work backwards. So put 2 into f, and whatever you get, put it back into the equation for f, right? I could probably do the working up here. f2, 5, 2 minus 6, right? Remember, we're going to replace x with what? 2. Somebody said the answer was 16. Not too sure yet. 5 by 2 is what? 10. 10 minus 6 is what? 4. Right. Now, when we put 2 into f the first time, we get 4. That new answer, we have to put it back into f. So for our final answer, we go to this equation and we replace the x with the answer we just got. 5 by 4 is 20. 20 minus 16 is 14. Okay? Be careful now. If they ask you for fx, and this whole thing is in brackets, and the squared is outside that brackets, right? So let's do it for a question. This question is actually easier. All you have to do is find, you're going to put 2 into f, and whatever you get, you square that answer. You think you all can do that for me? Put 2 into f, right? But we know what we're going to get. When we put 2 into f, we're going to get what? 4, right? So 2 into f is 4. And whatever we get, we square it. So the final answer for that one is 16. You notice for both of them, even though they look similar, we get different answers. And of course, because it's so easy to mix up the two, what do you think the examiner is going to do in the exam? He's going to look for an excuse to put these types of questions. Okay? Right, so I hope you don't make that mistake in your exam. Great, let's move on. Right, finding back the original price after a discount, loss, or profit or whatnot. If I have a map, so this pirate is selling you a map. Let's say this map is $120 and he plans to sell it to you. but he plans to make a profit, right? If the profit he plans to make is 45%, how much will you be buying the map for? Remember, he's making a profit on it. So that means you are going to pay more than $120, okay? Now, I'm going to do this the primary school way, right? How would you do this question? You would say, well, let's find 45% of $120. That will give you the profit he plans to make. So 45 divided by 100 multiplied by 120, and we're going to get what? $54. So how much will you be buying it for? Won't it be 120 plus the 54? That makes sense, right? So 120 plus the 54, you should be buying it for $174, right? Double checking it, 120 plus 54, $174. All right, so that's the primary school way, right? We will find the profit and add it back to the original price. So now let's work this in reverse, right? And I think you all saw this trick already, right? Let's say we don't know the answer is 120, right? So let me erase that. So somebody comes and erase this, and they come and ask you the question backwards now. You just bought a map for 174. The person made 45% profit. So how much did it originally cost the pirate? Now we know the answer is supposed to be 120. So here's what a lot of people will do. They say, all right, we'll just work it opposite. We're going to find 45% of the 174. So let's do that. 45 over 100 minus multiplied by 174. But we're getting $78.30. If we take the 174 and minus this, are we going to get back the $120? No, we're going to get 95.70. It does not give us back the original answer if we use a reverse concept. We find 45% of that and, work backwards. So how do we get the original answer? The easiest way you could do this is use the cross table. We're dealing with two things, percentage and money. You see the original price, whatever the original price was supposed to be, that's always regarded as 100%. So the pirate's price was 100%. And we don't know his cost. We're pretending we don't know. Remember, after he sold you it, he made 45% profit. So when you bought it at 145% off its value. So your percentage is 145, and that 145 is represented by $174. To find back X now, you would just simply have to do what? Cross multiply. Let's cross multiply. 145 multiplied by X, and then you'll get 74, 174 with two zeros. Throw across the multiply, you will get a divide, and we get back the $120. Just keep in mind, the original price is 100%. Everything else after, if it's a profit, like if the profit was 45, you add 45% to the 100. If it was a loss, then you would minus 45% from the 100. Okay, so you have to be real careful. These reverse questions are very tricky in the exam because you apply common sense to it. You say, well, if we're working forward, we add the 45%. So if I work backwards, then I should minus the 45%. But it doesn't work that way. All right. All right, so that's trick number 8. Let's hope you get this in the exam. That way you're going to get it correct. Okay. Number 9. Well, I think yesterday we did this, right? Whenever you have an inequalities to draw, right? Let's say you have to draw this equation. minus 2y is less than minus 2x minus 2, right? First things, whenever you're drawing a graph, you have to make sure who is the subject, y. So the first trick over here is the minus 2 is a multiply, you throw it across, you're going to get what? A divide. We're going to divide every one here by minus 2. Because when you throw across a multiply, you get a divide, but the sign does not change. Minus 2x divided by minus 2 is positive 1x. I don't have to put the 1. Minus 2 divided by minus 2 is positive 1. What mistake did I just make? There are actually two little small tricks in this. What's the first mistake I just made? Something is wrong with my answer. Right, Christian, you are correct, right? Guys, whenever you divide or multiply by a negative value, you notice we're dividing by a negative value. When you divide by a negative value, your inequality has to switch around, right? Okay, great. And if when we're drawing this graph, right, what we're going to do is choose some values for x and some values for y, right? So like if you choose x as 2 and x as 3, well, you're going to get what? 3 and 4. I'm just fast tracking this, right? So if we were to draw this, the first point will be 2, 3. The other point will be what? Sorry, small mistake there. 2, 3, and 3, 4. So I'm just saying, if you were to draw this graph, it would look something like this. Well, what mistake did I just make again? I just drew this graph, right? What's the mistake? We discussed this for those who came yesterday class. Great, Christian, you remembered. It's supposed to be a dashed line. Whenever it's less than or more than, it's supposed to be a dashed line. If it's more than or equal to or less than or equal to, it's a solid line. This question is just plain old more than. It doesn't have the little extra line underneath. So in the exam, when I'm drawing this, I have to make sure it's a dashed line. Otherwise, I will lose a point in the exam. And of course, if they ask you to shade it, you know, if they ask you to shade the required region or the wanted region, it's a more than. More than means you're going to what? Shade above the line. You realize you would have gotten the question wrong if you forgot to change the inequality around. Because if you forgot to change the inequality around because you divided by a negative number, you realize you would have ended up shading underneath the dashed line. You would have shaded the completely wrong region. All right, so but this should have been fresh in your head because we did it yesterday in class. Let's see if we can make number 10, right? Let's move on. I know we're coming close to half it. Right. This one is, I just want to make sure we understand this one. And I'm going to spend too long on this. Too many people get this one wrong. It's a simple mistake. When you're using the quadratic formula, right? We all know it, right? B squared minus 4 by A by C. Guys, remember the formula comes with a minus sign by the B. So if your B value is negative, when you put it over here, right? When you put it over here, sometimes because the B value is negative, the two negative signs will change to give you what? A positive. It won't happen all the time, but if the two negatives happen to touch, you have to remember to change it to a positive. All right, so I'm going to hold off this. This is just 10 common mistakes made by people who are writing CSEC maths. So guys, I'm hoping this helped you all, and you know,